Sure. Brett Stanton. You want the first name spelled?
Yes, please.
All right. Brett Stanton, Brett. Stanton is Stanton, and I am the manager of strategies and innovations at Superior Bone Asphalt.
Okay. So we're talking about the manager of innovations. How important is innovation to the asphalt industry?
I'd say it's very important. It's one of the ways we try to separate ourselves from our competition. So it's often that you'll innovate and then your competition will catch you, or so we're always trying to sharpen the pencil, if you will, and get better at what we do, because that helps us be more competitive in the DOT low bid environment.
How does that help the industry at large?
Helps tremendously, because industry obviously is moving forward instead of staying stagnant. So with intelligent compaction, infrared technology, scanning, smoothness stuff, all that, and SMA, like we're here talking about, all important things to keep the industry moving forward.
Can you think of some maybe some challenges, and then how through the competitive use of innovation your company and others are overcoming those?
Yeah, I think as far as challenges go, when innovating, you always want to be on the leading edge and not the bleeding edge. So you're kind of trying to balance risk with reward. Make sure you don't innovate outside of your parameters. As far as like an example, I would probably tie that back to like chemistry, whether it be warm mix or rejuvenators or recycling agents, using that technology to help us make better materials that allows us to be more competitive and win projects is probably a real recent example of innovating and kind of moving our business along, strengthening industry in the Kansas City area.
So if someone were to ask, why pave with asphalt? What would be your answer?
It's economical. It's 100% recyclable. It also lasts a long time. It's smooth. It's quiet. And like I said, I guess I'll repeat myself, but it's good performing. It lasts a long time. So
good. In terms of density and durability, can you talk about the relationship between density and improved durability and performance?
Yeah, I'd say there's a strong correlation between those two. Obviously, I think we've probably all seen examples of projects where the best mix as far as volumetrics gets laid and it doesn't get properly compacted and it doesn't last long out on the road, where there's materials that maybe there was an issue at the plant, where volumetrics were out or gradation was out, but it was properly densified out on the roadway and it's still performing adequately today. So.
That's good. What about the relationship? Well, I guess that's more of a kind of question repeats itself. So let me ask you this then: what are some critical things that DOTs need to consider when to ensure optimal density?
What I think the biggest thing is, what are they paving over? So I understand budgets are tight, and so there's we'd all like to tear it down and build it back from scratch, but that's not the real world that we operate in. But so what are you paving over? If you're milling something off and you've got distresses that are deeper down the pavement, or you've got a sub-base or a base issue, you have to be cognizant that it'll be difficult to get density if you're paving over something that is hard to compact against. So I'd say kind of what you're starting with.
So on the contractor side of the house, what do they need to do or ensure that they're doing in construction practices or other things to ensure good density?
I'd say training their employees on what the best practices are and doing it consistently. That's the thing. We have a lot of people on a paving crew, and they move from crew to crew from time to time, and so making sure everybody's trained, they know their role, and they know how to get the job done.
That's good. Are there challenges to training, and how are you guys able to mitigate those and make sure everybody's trained?
Yeah, I mean the challenge is we're paving 14, 16 hours a day. There's not a lot of time to sprinkle in training. So doing off-season training is a good thing, but then trying to get people to retain that is another challenging thing. So, how we do it is kind of do some off-season training, like I mentioned, and then also kind of sprinkle some stuff in, have a manager go out and visit crew and kind of isolate one thing, kind of talk about that and why you're doing it. So I think it really helps going out into the field and show somebody why you're doing it, because the crews, obviously, they know how to do their job. Sometimes they don't always understand why they're doing it, so it kind of helps drive that home when you can explain to them why they do things like that. So
that's good. That's good. So in terms of measuring density, what are some ways to measure density?
So in situ pavements can be cored, and that be either tested out in the field or run back to the lab to get a core density on. There's some nuclear devices out there that will check density. There's also non-nuclear devices out there that check density. Those are probably the primary ones that are in practice today. There's intelligent compaction that gives you an idea of what densification or at what degree the pavement is densified. It's not exactly a true correlation yet, but it's a good indicator for the roller operator to know when he or she is getting close to getting things compacted.
That's good. Now, what about in terms of quality control? What are ways that your guys or other contractors in the field can ensure quality control?
Quality control, you can't fix what you don't measure, so having a good quality control department is crucial in order to produce good quality and consistent pavement. From cradle to grave, moistures at the plant, or even gradations, I guess, while the material is being produced, to moistures before production, samples during production, samples out on the roadway, density out on the roadway, smoothness, all that stuff is very important to ensuring that you get a consistent product.
That's good, very good. You wrote some things out of that answer that had not or heard in other responses from folks, so that was great. So what about temperature? I mean, I know, right, temperature's got to be key, but how does it affect density?
It's the single most important factor in achieving density. If it's not there, you're not going to get proper compaction. So, to quote Jim Schrockman, the three most important factors of density are temperature, temperature, temperature. So, extremely important.
Now, is it just the right people at the right time, or is there technology or innovation involved in ensuring a proper temperature? Describe to me just a little bit about how those things work together to ensure that the compaction is happening at the right time.
I'd say it starts with communication between the plant and the roadway. So understanding what temperature needs to be out on the roadway gives the plant folks an opportunity to produce at that temperature. Getting feedback from the crew as it's coming out hotter than or not as hot as I want it, and then out on the roadway with the technicians checking behind each roller pass and developing a compaction curve in order to make sure you're not only achieving density, but you're optimizing density. So you're not beating the pavement up by over rolling it, but you're also not under rolling it. So kind of that constant feedback, and then monitoring things throughout the production cycle.
That's good. Now, what about the use of recycled asphalt materials? How do they affect density?
They bring some challenges as far as they stiffen up the material if you're not using some sort of chemistry to kind of aid in that densification process. Nothing that you can't or nothing that you can't overcome by doing your homework and understanding what that does. So it might be making it a little bit hotter, or adding another pass or two to the rolling operation, changing the vibration or frequency of that roller in order to ensure you're getting density, but nothing you can't overcome out in the field.
So what about recycled asphalt shingles?
I mean, similar to recycled asphalt pavement, stiffens up the mix. However, again, as long as you're monitoring what's going on, you can certainly get density with when using recycled asphalt shingles.
Yeah. We're hearing your audio on your phone.
Oh, no, I turned it on. It was turned up while we were in the break.
So talk about, Brett, warm mix asphalt, and are there how do you get correct or proper density using something like warm mix? I mean, I get and how that's phrased improperly. Are there nuances that one should consider when using warm mix to get proper density, or?
Yeah, I'd say so. Warm mix, I guess, for me is maybe different than most people think about warm mix. I'm not a huge fan of dialing down production temperatures, especially when using recycled asphalt pavement or recycled asphalt shingles. You have a very short window of time to transfer that heat from the virgin aggregates to the recycled product, and you need to activate that binder, because in the mix design process, that is part of the binder you count on. So lowering production temperatures, there's issues with, or potential issues with, having enough time to get the moisture out of the recycled product, get it up to temperature in order to get that binder activated to be part of the matrix. So warm mix to me is compaction aid. So using chemistry to help get density, whether it be colder outside or you have a mix that is too stiff to work with, or you have a long haul or something like that, or even a mix that is prone to segregation. Warm mix compaction aids, they can help the workability of the material, help it flow through the paver, and increase the product performance out on the roads.
That's good. So, did you say that you work with pavement design?
Yeah, I do.
Okay.
Yeah.
So let me ask you this: are there changes to pavement design and asphalt mixture design that would make achieving consistent density easier for contractors?
Yeah, I mean, it kind of goes back to budget things. Like we all wish there was more money available. Lift thickness is pretty important in achieving density. The DOTs, obviously trying to be budget conscious, have shrunk the thickness that's out there. So we're getting down to 3 times the nominal maximum aggregate size, sometimes below that, which makes trying to get those particles reoriented and get them compacted difficult. So that's one thing that could help, is increasing the pavement thickness. The other is as far as mix designs go, I mentioned to you earlier about balanced mix design, or looking at that approach where kind of what is the end goal, balancing rutting with cracking, and then let the contractor innovate and get there. So that would bring up more than likely would increase asphalt contents, which is something that we've been on this cycle of reducing asphalt contents to control rutting, and now the pendulum has swung the other way, and we realize that we found where the low point is, and now we got to swing back and start putting more asphalt back in the mix.
Now, how does new technology affect, improve, or ensure good density?
Well, giving, like, I guess new technology, think of like intelligent compaction, something like that gets real-time data to the operator. So I think that's very important to provide feedback when you think of a roller out on an interstate project at night. Even it's hard to see where you've been, where you need to go. So giving that real-time feedback is very important to ensure getting proper densification.
So we know that intelligent compaction is kind of the paint by numbers, right? Where the operator knows how many passes on a specific section. That data is captured, though, right? And what are the benefits of? Does it have study or research benefits down the road? Does that data live longer than just that day? And if so, kind of how is it used, and how does it benefit the future?
Absolutely. I think the the primary benefit is that real-time feedback, but the ancillary benefits are it allows the contractor to go back and review that information, or even the DOT, probably more beneficial for the contractor to go back and review how efficient that roller operator is, how long did they stop, what other information can they glean from that data. So there's, with the infrared scanners for temperature, the PAVE IR stuff, that has a number of benefits. Obviously, it gives real-time feedback to the crew to see that temperature is uniformly distributed across the mat, and they can change the screed adjustments, or make screed adjustments rather, to ensure that consistency. But then also you download that data, that gives you real-time, it gives you paver speed, it gives you how long the paver stopped, how long it was stopped for, there's a whole bunch of benefits that the contractor can use to make their operations more efficient and, in the end, make their product more economical for the end user.
That's great response, sir. Okay, so we talked about intelligent compaction. Are you able to speak to Veda 5? Do you?
I haven't used I've dabbled with it. I haven't really got in and kicked the wheels on it.
Okay.
ProVal.
Yeah, that's fine.
I could talk about ProVal.
Oh, really?
Yeah.
Okay. Where's that? I've got a ProVal question, I thought. All right, I'm just going to ask you. So talk to me. Tell me about ProVal. What is it, and how does it help?
So it's a profile analysis tool. It's a very useful tool. Many DOTs require that the contractor's profile data come in through that, get analyzed there, and then get uploaded to their systems in order to get paid, incentive, disincentive, whatever the case may be. But it's a very powerful tool. In addition to just the analysis, another thing contractor can look at and see what their smoothness is. There's a number of different tools in there that allows you to kind of look at the binary pieces of the profile. You can break it down into as many sections as you want to zoom in on it. There's a particular module in there that I'm trying to think the name of it now. It was right on the tip of my tongue when we started talking about ProVal, but it allows the contractor to go in and look at the wavelengths, reoccurring wavelengths that occur in their profile data, which might indicate that you're paving over a jointed concrete, or you have something wrong with your paver that keeps putting in a reoccurring wavelength, which is affecting the ride quality. So it's a very powerful tool.
Now, so we're actually somewhat familiar with ProVal on the concrete side of the house. Are there asphalt applications of ProVal?
Well, it's just looking at the ride stuff.
Okay.
So it's a ride quality only tool. So you can look at concrete pavements or asphalt pavements, but yeah, it's just analyzing the ride. So
so that data then helps the contractor. How? Talk about that use of that data, and then how that helps future operations. Or
sure. So it gives you feedback. Like I said, you can dissect the data however you want. You can break it into different segments, different segments than what the DOT might want you to look at. You can look at, if I do this, what is gonna, you can do simulations. Power spectral density is the module that I was referring to, where you can look at the different recurring wavelengths and how those might be impacting ride, because there are things with different pavers and how things, or if there's a roller operator that's turning out every 100 feet or whatever, you may pick that up on that and notice that, hey, we shouldn't be doing that. Or if they turn out too sharply, you can sometimes identify that on the profile, which you wouldn't otherwise. You might realize you're either getting a disincentive or you're not getting any bonus, you're just getting straight pay, but going in and looking at that data might move you from the straight pay to the incentive, and how can you maximize that bonus. It's a very powerful tool.
That's great.
I think it's also another thing too, is in the QC world, is verifying the data that you have. So making multiple passes, and then there's a profile or profiler certification module in there, so you can go compare profiles to one another to make sure that if you ran it twice and more or less it's the same profile, you can ensure yourself that you didn't, get off track, or that you collected, at least you were repeatable in your data collection.
So moving on to smoothness now. Can you talk about how does smoothness affect performance?
I think it affects it tremendously. There's obviously the more roughness there is to the pavement, the more dynamic loading you inflict into that pavement structure, which then degrades its performance. So the smoother you can make it, the less loading or the less dynamic loading you're imparting into the pavement structure.
And okay, because you just mentioned dynamic loading. Talk about how smoothness is used or should be used in pavement design.
That's a good point. I don't know. I don't work for the DOT, or have never worked for the DOT, so I don't know if they take that into consideration when designing pavement. Obviously, it's a factor in rehabilitation. When does a pavement need to be rehabbed? But I think it's something important to look at. Also, something important to look at in the design process, like if contractors given grades to hit, how do those grades translate into ride? I don't think that is ever really investigated. In fact, I don't know that. I'm sure you can figure it out. It's probably not the easiest thing to do, but it's important to understand what the designer put on paper when it's built. Is it going to produce a smooth pavement? If not, it should be corrected during the design process.
That's good. So, and you touched on this a little bit. How does smoothness correlate with future rehabilitation needs?
It's a primary indicator of when things need to be rehabbed. So whether it's I think it's 180, 160, 180 is the threshold that Federal Highways uses for when a pavement needs to be rehabbed. So it's important parameter. And it obviously, we all know when we ride on not so smooth pavements how that feels, and we obviously all like to ride on smooth pavements.
Good. Let's see here. Okay, here's one. Here's one that I think you'll be able to knock out of the park here, because you've already talked about incentives and disincentives when you were in a previous response. So how should DOTs use incentives and disincentives to support building smoother pavements?
I think it's a great tool to incentivize somebody to step up their game. I don't think the incentives should be handed out for subpar work, but I also feel the disincentives shouldn't outweigh the incentives. But they should be set, so trying to raise the competition to get it to a certain level. So I think it's a very important and useful tool in order to increase pavement smoothness.
What technology is available to help contractors build smooth roads?
So as far as the paving goes, well, I guess I can start from.
Hold on just a second. Let's start that over. Hear that? Mm-hmm. That one's new. I haven't heard that noise. Let me ask this question again.
Sure.
So what technology is available to help contractors build smoother roads?
Well, as far as material delivery, transferring material without impacting the paver through a mixed transfer vehicle is an important, I guess, an important characteristic or important thing to use to get smooth pavements. It's not 100% critical. You can do it without, but you have to be on your A game. As far as the paver goes, using an averaging ski of some sort, whether it be contact or non-contact, and then understanding how that tool works, and how to optimize that. Again, that takes time and understanding and experience in order to kind of dial that in. And then as far as there are some technologies out there that give you real-time smoothness. Bolt-on equipment that goes on the paver that gives immediate feedback to the operator as to how that pavement smoothness is, so before the the profiler comes out, because that's obviously after the pavement's cooled, there's not much you can do about it at that point. So that's relatively new technology that's coming down the pipeline. So.
That's good. Are you able to talk about MAP 21?
Not really. I mean, nah, not really.
Okay.
Other than I know it's a program.
Yeah, okay.
Yeah. Not that versed in that.
So let me ask you this then. How are smoothness specifications changing?
Well, I'd say, I don't know that they're changing dramatically. I think well, I guess I'll take that back. Smoothness specifications kind of moved from the old profilograph index to IRI, which, so kind of changing the language, getting people used to what IRI is versus PI. So it's changed in that sense. I think there's still a large discrepancy, at least the last time I looked. A number of states had different ride quality parameters for concrete versus asphalt, which I think is kind of a disservice to the traveling public, because my wife or my mother drives down the road, they don't care if they're driving on concrete or asphalt. All they want to know is that it's smooth. So what difference does it make what the medium is? We should get it as smooth as we can, and everything should be based on or judged on a single smoothness criteria.
That's good. All right, so the last thing, we're going to move into long life pavements.
Okay.
And I've got a few questions on that. What are some key...
Oh.
So, what are key factors to ensuring long life pavements?
Well, as long life payments, like we talked about before, quality control, you can't fix what you don't measure. So making sure that material production is consistent, that mixture production at the plant is consistent, delivery is consistent, and then the laydown operation is, again, consistent, as well as things get properly densified in order to ensure that long life pavement.
Now, the move to long life payments is kind of, as I understand, kind of a philosophical change really for the DOTs, because it represents a greater upfront investment, but yet they can look at that over the long period of time and really see where they see their ROI much later down the road. But so how does that though, how does that change in philosophy, how does that affect contractors, and how are contractors responding to that?
Well, I guess I don't have any exact experience with that, but I would guess I would see that as the contractors would embrace the fact that they're in long life pavement. You're more than likely, it's new construction. You're building it from the ground up, so you're building it right. I think they might also be a little nervous about the fact that the amount of projects is probably going to go down, because budgets are tied up with fewer projects instead of overlay projects. So one, you get the performance because you built the pavement correctly. It wasn't just an overlay. But two, obviously nervous about the reduced number of projects that are available to bid.
Okay. That's interesting point of view. I hadn't considered that, but yeah, I guess you're right. So it's the projects take longer, so therefore they are
Right.
And are more of a significant investment. So
Right.
therefore fewer dollars to do
Right.
a lot
Yeah.
of other things.
Yeah. So then, if there's normally 15 overlay projects, $1 million a piece, or there's two, projects that are full, perpetual pavements or whatever that are $7.5 million a piece. If you don't get one or two of those projects, you're going to be hurting. Where before you had 15 opportunities, kind of spread things out. So.
Yeah. Okay, that's good. That's a good point of view. I appreciate that. Are you able to talk about fatigue endurance limits relative to long life pavements?
I mean, I have a basic understanding. I mean, I'm certainly no expert on it, but
Okay.
obviously the premise of long life pavements is obviously reducing that fatigue at the bottom of the layer in order to protect what's below it. So designing proper thickness and having the correct asphalt mixture designed to be able to handle that fatigue loading without cracking.
Yeah. What about per road? Are you having experience with per road?
Yeah,
So it was
a little.
developed at NCAP for Napa.
Mm-hmm. Yeah, and I mean I've played around with it, but I've never used it as a design tool.
Okay.
There's not a lot of people designing perpetual pavements, at least in the contractor realm. Not a lot of customers coming to ask you to develop a perpetual pavement.
Yeah.
So.
Okay. What about ASHTO's pavement ME? Is that same
I've
concept?
used a little bit, probably like generation 1, or back when it was the Excel spreadsheet. That was the last time I
Okay.
used. I haven't used the new software.
Okay. What requirements would you like to see DOTs write into design standards in order to ensure long life pavements?
I'd say, I guess, what material selection, like what understanding, where they're at in the state, what local materials may go down on the project, and how those might affect performance. That's a huge part of knowing what you're going to end up building, is knowing what's going to go into the recipe. So having more of an emphasis on, and I understand it's hard, but having more of an emphasis on the unique the unique portions of the project, and not just have a kind of an overall encompassing CAN specification that's developed to handle everything. So I think you can obviously optimize, be more efficient that way. I understand there's more work involved in that process as well, but if we're going to make a significant investment to build, long life pavement, that's the time to do your homework. So.
Okay, that's good. So probably just 2 more questions then.
Okay.
I made a couple of notes when we first sat down. I already asked you about training. That's one of my notes. What performance issues do long life pavements alleviate or reduce?
I'd say fatigue. I mean, properly designed and constructed long life pavement would reduce or eliminate fatigue cracking that we see in some pavements out there, potentially rutting, and the main performance issues that are the 2 main performance issues rather that would be taken care of: cracking and rutting.
So, last question then is Brett, where do you see the future of the asphalt industry in the next 10 years?
I'd say the future of the industry, I think, is developing, or I guess rolling out, specifying performance testing to start to look at our mixes in a different way. Instead of prescribing how they need to be designed, we'll start to prescribe what they need to be built for, and then let the contractor innovate to get there. So I think that's really where the future is going, which should hopefully lower mixture costs, or in some cases it might raise mixture costs, but we're going to get more value out of that mixture because we're looking at it more scientifically under a microscope than we do now.
Yeah, that's good. That's a good answer. So, anything that I missed or anything that you wanted to add?
I don't think so. How is this just about pavement durability? I know we got into long-term or long-life pavements. What everybody, the industry question or whatever that you asked at the end there, I wasn't sure like if there was, challenges facing the industry or anything
Yeah,
like that.
that's a great idea. Let me ask you that question.
Okay.
And so what are the challenges facing the industry today?
I think the biggest challenge that we face is workforce. We've got a lot of people retiring, so trying to fill that void, get people trained, and get smart people that want to work in this industry, because it's hard work for sure. It's very rewarding work, but it's definitely hard work, long days in a hot atmosphere, out on the roadway where traffic's zooming by. So there's not a lot of people jumping to come aboard. So I think that's our biggest challenge is kind of replenishing that workforce and keeping things moving along.
That's good. I guess I did ignore the fact we're at the SMA conference talking about stone matrix asphalt. What is SMA's role, say, in long life pavements?
I think it's an example, a proven example of how pavements can be designed. Different mixture types can be used to stand up to the traffic that we see out there. So I think it's this conference in particular is a good tool to show people that might be on the fence or considering dabbling in SMAs or specifying SMAs on the performance benefits of SMAs. Also allows contractors to kind of mingle and talk about successes and failures when using SMA. So hopefully contractors that haven't made SMA can learn from those mistakes that have been made previous to their involvement.